What if everything you were ever taught about the beginning of the universe is only half the story? Not wrong, just incomplete. And the missing piece is so mind-bending, so outrageously extreme, that most people never hear about it in school. Sit tight, because the next few minutes will completely rewire how you think about existence itself. Here is a fact that should stop you cold. The entire observable universe, everything you can see through the most powerful telescope ever built, all 93 billion light-years of it, was once smaller than a single atom. Not the size of a marble, not the size of a grain of sand. Smaller than one atom. And then, in a fraction of a second so impossibly small that no human word truly captures it, it exploded outward at a speed that makes the speed of light look like a Sunday afternoon stroll. That event has a name: cosmic inflation. And it is not science fiction. It is one of the most tested, debated, and evidence-supported ideas in all of modern physics. Now here is where it gets controversial. And this is the part most channels skip over because it makes people uncomfortable. For decades, scientists operated under a simple idea called the Big Bang. The universe began hot, dense, and small, and it expanded. Clean, simple, neat. But there was a problem. Actually, three massive problems that the standard Big Bang theory could not explain. And when the data does not fit, real science does not cover it up. It digs deeper. The first problem was called the horizon problem. When scientists looked at opposite ends of the universe, regions so far apart that they could never have exchanged light or heat in the entire history of the universe, those regions had the same temperature. Almost perfectly identical, down to 1 part in 100,000. That is statistically impossible under normal expansion. How can two things that never touched look exactly alike? The second problem was the flatness problem. The universe is geometrically flat, not curved, not bent, flat. And for it to be this flat today, its initial conditions had to be tuned to a precision of 1 part in 10 to the power of 60. That number is so astronomically specific that random chance cannot explain it. The third problem was the magnetic monopole problem. Early universe physics predicted exotic particles called magnetic monopoles should be everywhere today. They are not. We have never found a single one. These three failures demanded a new explanation. And in 1980, a young physicist named Alan Guth sat at his desk and proposed something that initially sounded absolutely insane. What if the universe, in the first tiny sliver of time after the Big Bang, underwent a period of exponential expansion? Not just fast expansion, exponential. We are talking about the universe doubling in size at least 60 times, and possibly hundreds of times, all within somewhere between 10 to the power of negative 36 seconds and 10 to the power of negative 32 seconds after the Big Bang. To put that in perspective, that is a decimal point followed by 35 zeros and then a 1. A time so short it literally has no comparison in human experience. In that unimaginably brief window, the universe grew from something smaller than a proton to roughly the size of a grapefruit. That might not sound impressive until you realize it means space itself was expanding faster than light. And that is allowed under Einstein's general relativity because it is space that's stretched, not matter moving through space. Now here is where the controversy modern scientists are wrestling with comes in. We have never directly observed inflation. What we have is extraordinary indirect evidence. The cosmic microwave background radiation, the afterglow of the Big Bang itself, detected first in 1965 and mapped in spectacular detail by the Planck satellite in 2013, shows tiny temperature fluctuations that match almost perfectly with what inflation predicts. Those tiny wrinkles in the early universe became the seeds of every galaxy, every star, every planet, and every living thing that exists today. The structure of the cosmos we see now was written in the quantum fluctuations of that inflationary moment. Your existence traces back to quantum physics happening in the first trillionth of a second. But here is what scientists are still fighting about in academic journals right now. What powered inflation? The leading candidate is something called the inflaton field, a hypothetical energy field that drove this expansion and then decayed, releasing energy that became all the particles of the universe in a process called reheating. The inflaton has never been detected. Its exact nature remains one of the biggest open questions in cosmology. Some physicists, including respected names like Paul Steinhardt, one of inflation's original developers, have publicly challenged the theory, arguing it may be impossible to fully falsify, which creates a scientific tension that is very much alive today. And it goes further. If inflation happened, it likely did not happen just once. Many versions of inflation theory predict something called eternal inflation, the idea that inflation never fully stopped everywhere, that it keeps generating new regions of space-time constantly, each one potentially becoming its own universe with its own laws of physics. The multiverse is not just a Marvel movie concept. It is a serious, contested, peer-reviewed scientific hypothesis. Everything around you, the air, the chair, the device you are holding right now, is the aftermath of a quantum event that lasted less time than any instrument can measure. You are the universe looking back at itself, trying to understand its own origin. If this blew your mind, follow this page right now because we are just getting started on the deepest questions ever asked about reality itself. Now tell me this in the comments below, and I genuinely want to read every response. If inflation created the conditions for everything to exist, what do you think existed before inflation began?